I'm going to do a few notes off of 4.4. Like I said earlier, the two assignments for 4.3 and 4.4 are kind of mixed together. So you might encounter problems you don't know when you start it. So if you'll just watch more videos, you'll be able to pick them all up. Okay, so what we're going to do now is solve exponential equations. That would be an equation where the x value is up in the exponent. Now the whole point of a logarithm is to undo an exponential because they are inverses of each other. But your first thought, the easiest thing to do, is to try and write your equation with like bases. Because if you write it with like bases, you can avoid doing a logarithm altogether. So for example, in this problem, this is already written with a base of 2. 2, and it has 3x minus 8 as its exponent. I want to write this as a base of 2 also, if it's possible. And in this case it is. I can write 16 as 2 to the 4th power, because 2 to the 4th power gives me 16. If you can rewrite the bases like this, you can completely disregard the big base numbers, pull these numbers down onto the line. So I now have a big equation, 3x minus 8 equals 4. And now I just solve this like any equation. Add 8 to both sides, then divide by 3, and I get x equals 4. So of course that's the way you want to go. If you can possibly do these by changing your base. So let's do another one. Let's say I have 27 to the x plus 3 power equals 9 to the x minus 1. Now in this case, I'm going to have to rewrite both of them, but both of these can be rewritten with a base of 3. I can rewrite this as 3 to the 3rd. Now I need to put that x plus 3 in parentheses because it was all already up there together. And I can rewrite 9 as 3 squared. And again, the x minus 1 needs to be in parentheses. Now I have found like bases. I can cancel these like bases and write this as just a large equation down on the line as opposed to exponents. And then just solve this. So distribute, and then get all your like terms together. And this time I got x equals negative 11. So that was definitely easier than using a logarithm, or at least more familiar than using a logarithm. Let's do one more, because I know they like to put these on the computer. Let's say that I have, let me see if I can find one, just a second. Yeah, let's see I have this. Five to the 2 minus x equals 1 over 125. Now again, the first thing you want to try to do is to rewrite these with like bases. And I know I can write 5 to the 3rd would be 125, but this is 1 over 125. Well, don't forget, what puts something in the denominator is a negative exponent. So I can actually rewrite this. Let me do it in steps. Let's do this first. 1 over 5 to the 3rd. Now I can move that 5 to the 3rd up to the top by making its exponent negative. So I'll have 5 to the 2 minus x equals 5 to the negative 3. And now I have created for myself like bases. So I can just disregard my base and solve this as a regular equation. So I get x equals 5. So that wants to be that, you want that to be your first and primary move, is to first rewrite these with like bases if that's possible. Now if that's not possible, then your next thought is going to be to use a logarithm. And I will do that on another video.